In the previous video, we have discussed what is abnormal colligative property. So, in order to account for the abnormal cases, Van Hoff introduced a factor I, which is called Van Hoff factor. Due to abnormalities or due to association or dissociation, there will be a change or difference in the experimental value and theoretical value of colligative property. So, to account for this difference, Van Hoff introduced a new factor. It is indicated as small letter I. It is called Van Hoff factor, where I equal to observed osmotic effect divided by normal osmotic effect. Osmotic effect means the for colligative property. It may be osmotic pressure or elevation in boiling point or depression in freezing point or relative lowering of vapor pressure. So these four colligative properties, generally it can be represented as osmotic effect. Okay, so the Van Hoff factor I is equal to observed osmotic effect divided by normal osmotic effect. And we know the properties vary inversely as the molar masses of the solute. So I can be also written as, in terms of molar masses of the solute, I can be written as I equal to normal molar mass divided by observed molar mass. Okay, normal molar mass divided by observed. What is the molar mass of in the experiment? Okay, that is the observed molar mass. So Van Hoff factor I is equal to, in one equation or in terms of colligative property, it can be observed osmotic effect. That is the value of colligative property in the experiment divided by normal osmotic effect, its theoretical value. Or in terms of molar mass, it is written as I equal to normal molar mass divided by observed molar mass. This is the equation for calculating Van Hoff factor. So, what is the function of Van Hoff factor? Van Hoff factor, it is used to account for the abnormal cases. If this Van Hoff factor is not introduced, there will be a change or difference in the molar mass. From colligative property, we can calculate the molecular mass of the solute. If we are not considering the Van Hoff factor I, then there will be mistake in the calculation of molecular mass. So in the equations of colligative properties, we have to introduce the factor I. Okay. If there is no association or no dissociation, the value of I will be 1. Okay. Then, degree of association. What is meant by degree of association? It is the fraction of total number of molecules which combine to form bigger molecule. Or degree of association, it can be represented as alpha. It is the fraction of total number of molecule which combine to form bigger molecule. Out of the total number of molecule, how many molecules are associated? That is degree of association. For example, consider 1 mole of solute dissolved in a given volume of the solvent. We are taking 1 mole of the solute. Suppose in 1 mole of the solute, n simple molecules combine to form an associated molecule. Here we are considering association. That is one of the reasons for abnormality. So if n simple molecules are associating to form a bigger molecule, its equation is Na. A is the solute molecule. Na gives the arrow representing reversible reaction. Okay, Na gives An, n number of solute particles A associate to give a bigger molecule, and it is An. and alpha be the degree of association. Then the number of unassociated moles. The experiment we have taken 1 mole of the solute and alpha is the degree of association. So after association there will be 1 minus alpha moles of unassociated solute particle. So the number of unassociated moles will be equal to 1 minus alpha. Then the number of associated moles. Since association is taking place in n number of molecules, so the number of associated moles will be alpha divided by n. Then what will be the number of effective moles or the total number of moles in the solution? 1 minus alpha plus alpha divided by n. This is the effective moles in the solution. Then from that we know I is equal to observed osmotic effect divided by normal osmotic effect, or osmotic effect is colligative property. Colligative property is directly proportional to quantity of the solute in the solution. So observed osmotic effect. Here in experiment, what is the observed osmotic effect, or what is the total number of solute particle in solution? It is 1 minus alpha plus alpha divided by n. And normal osmotic effect, or what we are generally expecting, that is 1, because we have taken only 1 mole of the solute. So we expect 1 mole of the solute in solution also. But due to association, there will be a change in the number of moles of solute in the solution. So normal osmotic effect. Then I will be equal to observed osmotic effect divided by normal osmotic effect, which can be equal to 1 minus alpha plus alpha divided by n whole divided by 1. Here 1 minus alpha plus alpha divided by n. It means the number of particles in solution after association. Okay. It will be equal to m normal divided by m observed, where m is the molecular mass of the solute. So normal molecular mass divided by observed molecular mass. So this is the case of association. And then degree of dissociation. Like degree of association, degree of dissociation means the fraction of total number of molecules which dissociate, or out of total number of molecules, how many molecules are dissociating. So if we consider 1 mole of potassium chloride KCl solution, so electrolyte KCl in a given volume of water, if we are adding KCl in water, and here we have taken 1 mole of KCl, let alpha be degree of dissociation. Number of moles of KCl left undissociated is equal to 1 minus alpha, because at first, or the number of moles of KCl is 1, because we have taken 1 mole of KCl, and alpha is the degree of dissociation. As time is going, KCl will dissociate to produce K plus and Cl minus. So what will happen? The number of moles of KCl left undissociated will be 1 minus alpha. 1 is the initial concentration, alpha is the degree of dissociation, and 1 minus alpha will be undissociated. Then what is the number of moles of K plus and Cl minus? It will be alpha and alpha. Then total number of moles after dissociation, or after dissociation in solution, there will be 1 plus alpha moles of solute. 1 plus alpha. can be obtained by adding all these values, 1 minus alpha plus alpha plus alpha. Okay. Then the value is 1 plus alpha. So in experiment, the number of solute particles in solution is 1 plus alpha. And in normal, we are expecting 1 moles. So I equal to 1 plus alpha divided by 1. It is equal to normal molar mass by observed molar mass.